Plastics are everywhere in our modern world. From the water bottles we drink from to the smartphones we use daily, plastics have become an essential part of our lives. Their presence is so widespread that it's hard to imagine a day without encountering plastic in some form. Whether it's packaging, household items, or even medical devices, plastics offer convenience and functionality. But have you ever wondered what makes plastics so versatile and why they are used in so many applications? In this video, we'll explore the science behind plastics and the challenges of recycling them, starting with their role in everyday life. Understand plastics, we need to look at their basic structure. Plastics are made from polymers, which are long chains of repeating molecules. These polymers are usually derived from petroleum or natural gas. The process of creating plastics involves chemically bonding small units called monomers together. This process, known as polymerization, results in materials that are lightweight, durable, and flexible. These properties make plastics ideal for a wide range of uses, from packaging to construction. Let's dive deeper into how these polymers are formed and why they matter. Polymerization is the process that turns monomers into polymers. Monomers are small molecules that can join together to form long chains. When these chains are formed, the resulting material gains new properties, such as increased strength and flexibility. This transformation is key to making plastics that are both useful and adaptable. Manufacturers can control the polymerization process to create plastics with specific characteristics. This scientific process is at the heart of why plastics are so versatile and widely used. There are two main types of plastics: thermoplastics and thermosetting plastics. Thermoplastics such as polyethylene and polypropylene can be melted and reshaped multiple times. This makes them ideal for recycling and reuse. Thermosetting plastics, on the other hand, undergo a chemical change when heated. Once set, they cannot be remelted or reshaped, which makes recycling much more difficult. Understanding these two types is crucial for grasping the challenges of plastic recycling. Thermoplastics are a group of plastics that can be melted and reshaped multiple times. This property makes them highly recyclable. Common examples include polyethylene and polypropylene, which are used in packaging, bottles, and containers. Because thermoplastics can be processed repeatedly, they are often the focus of recycling efforts. Their flexibility and durability make them suitable for a wide range of products. Let's look at how thermoplastics contribute to recycling. Thermosetting plastics are different from thermoplastics. When heated, they undergo a chemical change that makes them hard and rigid. Once set, they cannot be melted or reshaped. This property makes thermosetting plastics difficult to recycle. Examples include epoxy resins and certain adhesives. These plastics are used in applications where strength and heat resistance are important, such as electronics and construction. Their inability to be remelted poses a significant challenge for recycling. One reason plastics are so widely used is their versatility. Manufacturers can add different chemicals or additives to change properties like strength, transparency, and resistance to heat. This flexibility allows plastics to be used in packaging, construction, healthcare, and electronics. The ability to tailor plastics for specific needs is a major advantage, but it also complicates recycling. Let's explore how additives affect plastic properties. Additives are chemicals added to plastics during manufacturing to enhance their properties. These can include colorants, stabilizers, and plasticizers. By adjusting the type and amount of additives, manufacturers can create plastics that are stronger, more flexible, or resistant to heat and UV light. While additives improve performance, they also make recycling more complex. Different additives require different recycling processes, which can limit the efficiency of recycling programs. Plastics are used in countless applications. In packaging, they provide lightweight and durable containers. In construction, plastics offer flexibility and resistance to weather. Healthcare relies on plastics for sterile equipment and medical devices. Electronics use plastics for insulation and protective casings. The wide range of uses demonstrates the importance of plastics in modern society. However, this diversity also creates challenges for recycling. Diversity of plastics creates a major problem for recycling. Different types of plastics must be separated before they can be processed. Mixing them can result in weak or unusable recycled material. This is why plastic products often have recycling codes, numbers that identify the type of plastic. Proper sorting is essential for efficient recycling, but it's not always easy. Let's look at how recycling codes help with sorting. Plastic products often have recycling codes printed on them. These codes are numbers that identify the type of plastic used. For example, PET is labeled as number 1, while HDPE is number 2. These codes help recycling facilities sort plastics correctly. Proper sorting ensures that recycled materials are strong and usable. Without these codes, recycling would be much less efficient. Understanding recycling codes is key to improving plastic recycling. Recycling process usually begins with collection and sorting. Plastics are gathered from households, businesses, and public spaces. Once collected, they are sorted by type and color. Sorting is crucial because different plastics require different processing methods. Automated systems and manual labor are used to separate plastics. Proper sorting improves the quality of recycled materials and reduces contamination. After sorting, plastics are cleaned to remove contaminants like food residue, labels, and dirt. Cleaning is an important step because contaminants can affect the quality of recycled material. Washing and rinsing ensure that plastics are ready for further processing. Clean plastics are more likely to be successfully recycled into new products. This step helps maintain the integrity of recycled materials. Once cleaned, plastics are shredded into small pieces. Shredding makes it easier to melt and reform plastics into new shapes. The small pieces are more manageable and can be processed efficiently. This step is essential for creating uniform pellets that can be used in manufacturing. Shredding also helps remove any remaining contaminants. After shredding, plastics are melted and reformed into pellets. These pellets are the raw material for manufacturing new products. Melting allows plastics to be reshaped and reused. The process must be carefully controlled to avoid degrading the quality of the material. Pellets are used in a variety of applications from packaging to automotive parts. Recycled plastic pellets are used to manufacture new products. These products can include bottles, containers, packaging, and even clothing. The use of recycled plastics helps reduce the demand for new raw materials. It also lowers the environmental impact of plastic production. However, the quality of recycled products depends on the purity and type of plastic used. Despite efforts to recycle plastics, only a small percentage is actually recycled. Contamination, high processing costs, and the complexity of sorting all limit efficiency. Some plastic degrade in quality each time they are recycled, a process known as downcycling. This means recycled plastics may be used for lower quality products. Understanding these limits is important for improving recycling system. Downcycling is the process where recycled plastics lose quality with each cycle. Instead of being used for high-quality products, downcycled plastics are often used for items like park benches or construction materials. This loss of quality limits the usefulness of recycled plastics. Downcycling is a major challenge for creating a sustainable recycling system. Contamination is a significant issue in plastic recycling. Food residue, labels, and other materials can make plastics difficult to recycle. Contaminated plastics may be rejected or require extra processing, which increases costs. Keeping plastics clean and sorted is essential for successful recycling. Consumers play a role by rinsing containers and removing labels before recycling. High processing costs are another barrier to efficient plastic recycling. Sorting, cleaning, and processing plastics require specialized equipment and labor. These costs can make recycling less economically viable, especially for low-value plastics. Improving technology and reducing costs are key to expanding recycling programs. Sorting plastics is a complex process. Different types of plastics must be separated to ensure quality. Automated systems use sensors and machines to identify and sort plastics, but manual sorting is still common. The complexity of sorting limits the efficiency of recycling programs. Innovations in sorting technology can help improve outcomes. Plastics can degrade in quality each time they are recycled. This degradation is caused by heat and mechanical processing. As a result, recycled plastics may not be suitable for high-quality applications. Quality degradation is a major challenge for creating a circular economy for plastics. Circular economy aims to keep materials in use for as long as possible. For plastics, this means designing products that can be easily recycled and reused. The goal is to reduce waste and minimize environmental impact. Achieving a circular economy requires innovation in materials, recycling technology, and consumer behavior. Plastics have a significant environmental impact. Improper disposal can lead to pollution in oceans, rivers, and landfills. Recycling helps reduce this impact by keeping plastics out of the environment. However, the low recycling rate means much plastic still ends up as waste. Addressing environmental concerns requires better recycling systems and consumer awareness. Plastic pollution is a global issue. Plastics can persist in the environment for hundreds of years. They break down into microplastics, which can harm wildlife and ecosystems. Reducing plastic pollution requires proper disposal, recycling, and the development of biodegradable alternatives. Microplastics are tiny plastic particles that result from the breakdown of larger plastics. These particles can be found in water, soil, and even the air. Microplastics pose risks to wildlife and human health. Addressing microplastic pollution is an important part of managing plastic waste. Biodegradable plastics are designed to break down more quickly in the environment. These materials can help reduce plastic pollution. However, biodegradable plastics require specific conditions to decompose, such as heat and moisture. They are not a complete solution but can be part of a broader strategy to manage plastic waste. Innovations in recycling technology are helping improve efficiency. New methods include chemical recycling, which breaks plastics down into their original monomers. This allows for higher quality recycled materials. Advances in sorting and processing are also making recycling more effective. Continued innovation is key to solving the plastic waste problem. Chemical recycling is a process that breaks plastics down into their original monomers. This allows for the creation of new, high-quality plastics. Chemical recycling can handle mixed and contaminated plastics, which are difficult to recycle mechanically. This technology has the potential to greatly increase recycling rates. Mechanical recycling is the traditional method of recycling plastics. It involves collecting, sorting, cleaning, and melting plastics to create new products. Mechanical recycling is effective for certain types of plastics but has limitations. Contamination and quality degradation are major challenges. Combining mechanical and chemical recycling can improve outcomes. Consumers play an important role in plastic recycling. Proper sorting, cleaning, and disposal of plastics help improve recycling rates. By following recycling guidelines, individuals can make a positive impact. Consumer awareness and participation are essential for successful recycling programs. Government policies can support plastic recycling. Regulations may require manufacturers to use recycled materials or label products with recycling codes. Incentives and funding can help expand recycling infrastructure. Effective policies are needed to address the challenges of plastic waste. Industries are developing initiatives to improve plastic recycling. Companies are designing products for easier recycling and using more recycled materials. Collaboration between manufacturers, recyclers, and governments is essential. Industry efforts can drive innovation and increase recycling rates. Plastic recycling is a global effort. Different countries have varying recycling systems and rates. International cooperation is needed to address plastic waste. Sharing technology and best practices can help improve recycling worldwide. Education and awareness are key to improving plastic recycling. Teaching people about proper sorting, cleaning, and disposal helps increase recycling rates. Schools, media, and community programs can spread information. Awareness leads to better recycling habits and reduced waste. Future of plastics depends on innovation and sustainability. Developing new materials, improving recycling technology, and changing consumer behavior are all important. Sustainable plastics and better recycling systems can help reduce environmental impact. The journey toward a sustainable future for plastics is ongoing. Sustainable materials are designed to minimize environmental impact. These include bioplastics made from renewable resources and recycled plastics. Using sustainable materials helps reduce reliance on petroleum and lowers waste. The development of new materials is an important part of the solution. Designing products for recycling is a key strategy. This involves using fewer types of plastics, avoiding unnecessary additives, and labeling products clearly. Design for recycling makes it easier to process materials and improves the quality of recycled products. Manufacturers play a crucial role in this approach. Extended Producer Responsibility (EPR) is a policy approach that holds manufacturers accountable for the entire lifecycle of their products. EPR encourages companies to design products that are easier to recycle and to take responsibility for collection and disposal. This approach can help reduce waste and improve recycling rates. Alternatives to traditional plastics are being developed. These include bioplastics, paper-based materials, and reusable containers. Using alternatives can help reduce plastic waste and environmental impact. The adoption of alternatives depends on cost, performance, and consumer acceptance. Community involvement is essential for successful recycling programs. Local initiatives, recycling drives, and educational campaigns can increase participation. Communities can work together to reduce waste and promote sustainable practices. Collective action makes a difference in managing plastic waste. Corporations have a responsibility to manage plastic waste. Many companies are adopting sustainable practices, such as using recycled materials and reducing packaging. Corporate responsibility includes transparency, reporting, and commitment to environmental goals. Businesses can lead the way in reducing plastic waste. Technological advances are improving plastic recycling. New sorting machines, chemical recycling methods, and biodegradable materials are being developed. Technology can help overcome challenges like contamination and quality degradation. Continued investment in technology is vital for a sustainable future. Global collaboration is needed to address plastic waste. Countries can share technology, best practices, and resources. International agreements and partnerships can help create effective recycling systems. Working together ensures a more sustainable future for plastics. Plastics are an integral part of modern life, but their widespread use presents significant challenges for recycling and sustainability. Understanding the science behind plastics, the recycling process, and the obstacles faced is crucial for making progress. With innovation, education, and collaboration, we can work toward a future where plastics are managed responsibly and their impact on the environment is minimized.